activity delivery on utilizing how the flooding could be converted into farming. Because we all know that flood is a very biggest threat for us. For instance, we do know most of the regions where rainfall is predominant, when they are cultivating, if the water is in more amount or more in volume, obviously that plant will get spoiled off. Am I right? So that means the flooded water is a very big threat. It is a very big question mark for us. So what we are trying to do today is, maybe we will try to look in for solution where this kind of flood water could be converted into farming without having any impact on cultivation, so that it will be a biggest boom rather than threat. Am I right?
Yes.
Okay. So I hope you guys can come up with a solution, and either the solution could be one or different. It is dependent upon you. So can you all do that? Whether you want to give one solution or different individually. What do you want to do? One solution. I am fine with that, and I want you all not to stop here. You guys have to give me the solution and convert them into a project also. Can we do that?
Yes.
Okay, over to you.
So the delta villages often experience two opposite problems: severe flooding during monsoon seasons and water shortage during farming periods. So the heavy floodwater damages the crops, houses, roads and livestock. At the same time, farmers struggle to find enough water for irrigation during summer. So our idea is to divert excess floodwater into storage ponds and canals, filter it naturally and reuse it for farming. So this system helps villages to reduce flood damage, store water efficiently, improve agriculture, support sustainable farming. So now let us explain the design thinking process behind our solution.
Okay, so what is the first stage?
Later I will explain the empathy stage. We face the problems by living in the data regions. We identify the major stakeholders, farmers, villages, and the local authorities and agriculture workers. We understand that during heavy rainfall, river overflows, agricultural land gets submerged, soil fertility decreases, transportation becomes difficult. Many farmers lost their crops completely. After a few months, the small villages suffer from lack of irrigation water. We realized that the main issue is poor floodwater management. Instead of allowing floodwater to get the waste into the sea, it can be collected, diverted and stored for future agriculture uses.
Okay, so that means you are looking in for every other corners also. Fine. What else is there?
So next on this define stage, we can clearly identify the core problem. The problem statement is how might we reduce flood damage in delta villages and convert excess flood water into a useful resource for agriculture. From our analysis, we found that floodwater is not properly diverted. Villages lack of storage problem and the rainwater harvesting methods are limited. Irrigation depends mainly on seasonal rainfall. So our objective becomes to create a low-cost and sustainable floodwater diversion system to store excess water supply, to reuse water for irrigation during dry season. Our design should be also eco-friendly, affordable, easy to maintain, suitable for rural village.
Okay.
The next stage is Ideate stage. In Ideate stage, we discuss multiple possible solutions. Some ideas include underground water storage tanks, smart drainage system, artificial ponds, canal diversion networks, recharge wells. Finally, we selected a combined system consisting of flood diversion canals, storage ponds, natural filtration beds, solar powered water pumps, irrigation pipes. Working principle of this stage. During floods, excess river water enters diversion canals. The water is diverted towards storage ponds. Filter layer using sand and plants help clean the water. The storage water is later pumped to agricultural fields for irrigation. This stage reduce water wastage and support farming throughout the year.
So the idea is coming up good. So let us see whether it could pass around.
In the prototype stage, we created a simple model to represent our idea. The materials are used cardboard base, clay or thermocol, plastic pipes or straws, blue paper for water flow, small plants or green paper, mini pond structure. The river is placed near the village area. Diversion canals guide floodwater away from houses. The water reaches storage ponds. Filtration sections clean the water naturally. Solar pumps transfer stored water to farms through pipelines. The advantages are prevents water stagnation, reduces flood damage, stores water for dry seasons, supports sustainable agriculture, uses renewable energy through solar power. This model demonstrates how villages can convert a disaster into a useful resource.
Okay, very good. So from the idea and the prototype, it seems good. So what you would like to conclude here?
Here the last stage is considered as a testing stage. In a testing stage, we could evaluate whether our system could efficiently reduce flooding and support farming. So expected results like reduced flood impacts on houses and fields, better water storage capacity, improved irrigation during dry seasons, increased agriculture productivity, reduced dependence on the groundwater. These are expected results. But in social impact, helps farmers economically, protects village infrastructure, promotes water conservation, encourages sustainable development, etc. So in environmental benefits, we considered it prevents soil erosion, supports groundwater recharge, reduces water wastage, promotes eco-friendly farming, etc.
Fine. So the thing is, I thought you guys will miss something somewhere, but you have covered everything, because the main scenario here is the water which is impure, the water which consists of more salinity couldn't be used for irrigation. So what you have done here, in the sense, you are trying to filter them. After filtering them, you are trying to utilize them at the irrigation. So that comes a very good betterment here. So if that's the case, any water that could be treated could be utilized for irrigation, so that the water wasted could also be reused, and also we can look in for several other sources that would be helpful for us in irrigation. Here, the major condition that you guys have to know is the one thing, flooding. Flooding in the sense the water will flow in very higher speed. So initially you have tried to reduce the velocity also. That also gives you a very good solution, so that the stagnant water could be filtered and removed and drained off and then reused. And the flooded water, the velocity could be reduced, and then we are draining it off and we are pumping them inside. So obviously this will become a very good technique. What I suggest here, in the sense, looking for several other solutions, try to incorporate everything together and use it in the irrigation. Okay? Can we all do that? Okay. So this is what I was trying to speak with you. By the next class, I want to come up with a proper, combined and upgraded solution. Okay? See you in the next class. Thank you.
Thank you.